Once again, good morning, everyone. We are here for our monthly online webinar. Today, what we are going to discuss today is about the healthcare sector and also how to approach industrial symbiosis with valorization and another green topic. And for that, we will have here three speakers, Ramos, Chorbev, and Vijay Lakshmi. I'm going to make a kind of outline of the three presentations that they will do. One will be how to power healthcare facility through medical waste valorization, strategic integration of digital health in the EU, and the last one, circular supply chain and industrial symbiosis in healthcare. As always, you have the question box in the low part of the screen, so you could ask any question to the three of the speakers. But before leaving the floor to the den, I would like to present each of the speaker today. The first one will be Ana Ramos. She is bachelor in chemistry. Later on, she did a master in environmental analytical chemistry, and she finalized with a PhD cum laude in environmental engineering, all in Portugal. She is working at INEGI, that is a research center, and she works in national and international R&D projects, especially with academic, technological center, or even companies. She has expertise in chemistry and environment, mapping and supporting development of circular economy strategy, and thanks to that, she has been author and editor of several scientific publications on the topic of environmental sustainability, waste energy, or even life cycle assessment topics. So she will be our first speaker. And second, we have Ivan Chorbev. He is professor and head of the software engineer department at the Faculty of Computer Science and Engineering in the University of Ucrania. His main interests and activities: software engineer, machine learning, ERP system, but also she have been working in e-health sector. Also, he served as dean of the faculty 7 years, and also as member of board of director in the business accelerator. Also working in the innovation agency of the country North Macedonia, and even in other countries like Serbia as a fund for innovation. He also worked as a consultant and in several research projects and international projects like FP7, Digital Europe, Horizon Europe, etc. And also as an academic, he has more than 100 research papers published. And last but not least, we have Vijay Lakshmi. She's a doctoral candidate in accounting and finance at the University of Esther, Finland, and she will complete her PhD soon. She working in sustainability challenges facing health system work life. She is also active member in the Academy of Management and the British Academy of Management, and she prepares several international work and conference like accounting and management. Apart from that, also she did, for example, a research visit in the University of Auckland to try to work in her idea. But in general, let's say that also she worked not only in the healthcare operation, but also in circular economy principles, sustainable transition, and other green topics. So that are our three speakers, and I'm going now to give the floor to Anna to start with her presentation of for her.
Thank you, Almudena. I'm starting to share my screen. Let me know if you can see it correctly.
Yes, in full screen, you can start. Thank you.
Perfect. Thank you so much for the presentation, and thank you all for being here today. So I'll take up the next 10 to 12 minutes to talk a little bit about how to power healthcare facilities through a medical waste valorization. Let me just see which of the keyboards will work for you. None. Okay. Okay. So starting with a little bit on the introductory side. We all know that waste is a massive problem in our society, namely medical waste, which amounts to tons annually. And this has even got worse since the COVID era, and has not lowered its production since then. So back then, like from 2020 to 2024, more or less, there were peaks of 280 tons of medical waste produced per day in the world. So this is a massive problem that we need to take care. And this type of waste includes materials, for instance, such as contaminated masks, gloves, metallic needles, sharp objects, catheters from healthcare facilities. So, and they can be contaminated both with medicines, but also with biological fluids. So they are considered hazardous and toxic wastes. And the specific composition varies throughout plastics, sharps, some organic matter, of course, and contaminated textiles. And the current disposal methods are not the most effective ones sometimes, and they can pose some environmental harm and health risks. You can see here in this graph the composition, the average composition of a sample of medical waste. So plastic is the major component, and then paper and organic follow. And as you can see here, there are at least 3 different streams that we can separate or segregate this type of wastes into. So a general section with recyclable and non-recyclable components, so they can follow the common lines, separating lines for waste disposal or recycling strategies. And then there's the hazardous part, which has chemicals in it, toxic substances, pharmaceutical components, sometimes radioactive elements also. So this is the most worrisome part that needs to be taken care. Right now, the common practice is to landfill and incinerate some of these fractions, but these have their implications. Namely, landfilling takes up a lot of valuable space, and there's also the potential for leachate contamination for the soil surrounding the disposal site. Regarding traditional incineration, it can sometimes, depending on the, let's say, on the filters or on the cleaning steps after the incineration takes part, they can release some harmful pollutants if not properly managed. And together with this, both techniques have high costs associated not only to the treatment itself, but to the transportation of the harmful wastes to the sites. So there is the need for a set of more sustainable and efficient solutions, and it is critical to solve this issue as the amount or the pile of medical waste continues to grow. So this is where the waste to energy techniques can have their play. So I'll show you a bit what the contribution can be for a cleaner and safer solution for this type of wastes. So as shown here, instead of being directly disposed, medical waste can be valorized, namely energetically valorized, as it can also be done already through incineration, but there are other techniques that can join this party. So these incorporate not only incineration, but also pyrolysis, torrefaction, for instance, gasification, plasma melting. So I will not go through all of these techniques, but some of them will be explained in the next slides. And the goal here is to convert as much as possible the residues into energetic assets, let's say, like heat, power, gas, biogas, some fuels, for instance, as you can see here in the green blocks. So the core idea is to grab the energy contained in the waste itself. So this is where we could take advantage of the waste inside the facilities of the healthcare infrastructure. So if there is a decentralized system to convert this waste into energy, it can be used in-house. So the hospital or the clinic, whatever, can use the energetic content of the waste it produces to power itself. The process, most of these processes reduce the waste volume up to 90%. So this overcomes some of the land use problems related to the nowadays used strategies. And this energy can either be directly used in the facilities or sold to or exported to other businesses or to the local energy grid or the national energy grid, depending on the situation of each country. So these waste-to-energy plants are equipped with emission control systems that help to lower down the pollutant emissions and make them a clearer and more efficient alternative compared to the traditional disposal methods. So a little bit on gasification and pyrolysis. So gasification, these are a bit different from incineration. Incineration is based on a combustion process, and gasification is also some kind of decomposition of waste, but in a low oxygen environment. So it produces a synthetic gas called syngas. Pyrolysis heats the waste in the complete absence of oxygen. So it kind of melts down and breaks down the molecules that compose the waste at high temperatures, resulting in fewer toxic emissions compared to traditional incineration. And we can achieve bio-oil, syngas, and some char. Each of these different streams can be valorized into several different products. And both syngas and bio-oil can be used to produce fuels to generate the power that could then be used in the facilities. Regarding impacts, so in terms of environmental sustainability, there is a reduction of landfill dependence. So by reducing the waste volume by such a large margin, these facilities conserve precious landfill space, which is a major win for urban areas, for instance. In terms of energy production, it generates renewable energy. So instead of relying solely on fossil fuels, we can use a consistent and more reliable waste stream, which is always being produced to power hospitals or even our own homes or businesses. And it destroys hazardous materials. So the intense heat of these processes effectively destroys these chemicals, these pathogens, these hazardous components of the waste, ensuring a safer and more environmentally sound waste disposal solution. And through all of this, they create an economic opportunity, so making a revenue stream for the facility and reducing the operational costs. In terms of energetic and exergetic efficiency, so plasma gasification has a high energy efficiency, so more than 66%, and the exergy, which is the capability to produce work from the system that is being converted, also around 66% when integrated into a polygeneration system. So not on an isolated way, but integrated into a more complete production system. And gasification has values a little below plasma gasification, but also between 50 to 60% of efficiency. And incineration, there are the traditional incinerators and a more modern era of incinerators, and these more modern ones can achieve high thermal energy utilization for steam generation, and then with steam, electricity can be produced. So regarding the economic outlook, and I'm almost finishing, plasma gasification has a very interesting and short payback period, which is it's a great opportunity for investors. So most of the times for a waste to energy plant, let's say an incineration site, investors expect something between I would say 12 to 20 years of operation, or even more, like 25. So comparing that to a plasma gasification system or even a hybrid system, which we see here that offer around 3 to 4 years of payback period, this is very appealing for the investors. So this is an opportunity to implement this kind of systems. And regarding the more modern plants, there is also a concern about the social aspects, not only the economic ones, but the social aspects, namely the communities surrounding the sites. There are very interesting projects, namely in Copenhagen and also in Vienna, with a more architectural feature surrounding the waste management sites, and also some leisure activities to engage with the population and have public acceptance. So there's always this component, this more human side of technology also considered. And as a snapshot of what I just mentioned, so powering the healthcare facilities with the waste that they themselves produce in-house has this transformative potential of creating energy assets indoors and not being dependent on energy from the grid or from different types of sources. These solutions are very scalable, so they are available for different scales and different types of healthcare operations. Regarding the environmental and economic benefits, there is this dual benefit, because at the same time we are managing waste and producing a sort of renewable energy. And then if there is the option to choose more advanced solutions, it means that we are investing in cleaner air, safer neighborhoods, and more resilient energy grids for today and for tomorrow. So resilience is also here taking into account. And this is a super interesting sort of industrial symbiosis, because we are taking waste and producing not only new products, but also less, let's say, tangible asset, which is energy and all the sorts of products that come based from energy, which is one of the most important assets nowadays. And we all know about the geopolitical and societal context that surrounds these kinds of assets. So thank you very much for your attention. And if you have some questions, I don't know, Almudena, now or then in the end after all the presentations.
I I think I could go for the question because it's only one, so maybe everyone has more fresh the ideas. First of all, thank you for your kind presentation and for interesting topic that you arise. The question is from Francis mention, do the plants in Vienna and Copenhagen treat hard material or just municipal material?
Municipal against, what was the first option?
Hard material, yeah.
Hazardous.
Yeah.
Okay, I think they are mainly directed to municipal waste, so urban wastes. But there is a super integrated system with lots of different types of components. I'm not sure, but I believe they have the capability to take care of hazardous waste also. But I can check directly and answer you by the end of the other presentations if there is no problem.
Okay, perfect. Thank you, Anna.
Thank you.
Okay, so let's move for the second presenter. Ivan, the floor is yours.
Hello, hello. I hope you can all hear me. Let me share my screen. I guess this is the screen I should share. Can you see my slides?
Yes.
I hope you can see them now in an expanded format, right?
Yes.
Okay. So my name is Ivan Chorbev. I'm a professor in the computer science faculty, computer science and engineering at the University Saints Cyril and Methodius in Skopje in North Macedonia. My PhD 17 years ago was about e-health and healthcare, computer science in healthcare. So, aside from other research in the past years, I've continued researching in the same domain, and it's my pleasure and an honor to be invited by Almudena here to participate this webinar. I hope we can jointly go through some of the recent developments in the European health sector, especially the European health data space, and its impact on the integration, in a sense, of the healthcare services throughout Europe, especially in an era where AI is a dominant buzzword that surely has an impact in the way health data is processed, analyzed. Of course, we can tackle the benefits of AI applied to healthcare data, but also the risks associated with it. So, last year, the European Health Data Space Regulation was activated. And I believe that this approach will have a lot of impact on the sustainable use of data and reduction of waste and reduction of bottlenecks in the application of healthcare services to patients all across Europe, especially ones that move around, that travel, that change jobs across the Union, enabling more informed, more tailored healthcare approach without the risks of the background healthcare data available for a particular patient. So the primary use of this European health data space is to exchange summaries of patient data and e-prescriptions not later than 2029 via a European-wide healthcare application, which will bring benefits to patients if they have health issues away from home or in a recently adopted new home across Europe. When they visit their physicians, the patients will get correct diagnosis based not only on their current symptoms, but based on their patient history, which will hopefully be readily available to the new physician attending to them rather than the old physician that was available in their previous home. A crucial, important aspect of European health data space is the secondary use of data, which means using medical data for research and new medical achievements, new diagnostic procedures, novel applications of AI algorithms over patient data so that we improve both diagnostic and treatment procedures based on knowledge we acquire after processing vast amounts of data. So I will tackle this secondary use of data later on. Another aspect would be interoperability. So exchanging European health records across countries will enable Europe-wide integration, seamless integration, and should hopefully reduce healthcare costs. Unnecessary healthcare procedures will not be done since there will be synchronization and reuse of previous diagnostic procedures. And of course, at the end of the day, all these regulations in Europe will hopefully empower the patients to have full control over their health data. They can decide whether their data can be used for medical research or not. They can decide about the extent of privacy of that data. They can decide whether their data can be moved around or not, whether it can be used for their own benefit or the benefit of mankind in general. So, what does the European health data space bring? Hopefully, harmonized standards. So, the idea is to have all across Europe to have common data models and coding standards so that data can be exchanged across Europe. Uh, we can have cross-border research access, which means that research institutions and teams, scientific teams all across Europe can have anonymized access to anonymized health data so that we keep the pace with the research being done in the United States and in China. You are well aware that AI has been advancing significantly across the world, but not so much in Europe. Some GDPR over-regulations have suppressed the progress of AI research in Europe, and also unharmonized standards for storing data, national legislation limitations, limited regulations for accessing anonymized healthcare data across countries has prevented big data analytics in the European continent. Therefore, hopefully, this European health data space will enable, maybe even through federated learning that I will tackle in the next slides, will enable researchers in Europe to accelerate the amount of research they are able to do over European health records so that we close the gap between research done elsewhere and research done in Europe because of several reasons. First and foremost, in the modern age, it's not good to be technically backward and to not achieve technical achievements comparable to other regions in the world. And another issue would be specific healthcare issues in Europe cannot be appropriately tackled or solved with research done on patients elsewhere in the world. We live in our own region, we have our own healthcare habits, we have our own fitness habits, we have our own food habits and ways of living, and therefore our healthcare issues are specific to our region based on our lifestyle, food, and so on. So, research on patients in China cannot be fully applicable to the issues we are facing here. So we can't rely on research done elsewhere on other people living other different lives. So we need European data medical research so that we tackle our health issues in Europe. Data governance is important. Healthcare data is one of the most delicate and sensitive personal data. Therefore, the European health data space regulates exactly in a proper manner how people can manage their own healthcare data. As I mentioned, the primary use of clinical data is important for good diagnostics and treatment decisions, for proper prescriptions and monitoring of patients, for generating electronic health records that can be first and foremost used for the personal diagnostic of the patient itself, himself, herself, and management of the patient. But even more important, the secondary use of data, where European researchers can do proper epidemiological research, training, and innovation of AI models over this European data, the assessment of health technology, the monitoring of public health, and policy design. Well, it's important in a sustainable economy and trying to optimize the health processes, if we're trying to minimize procurement of unnecessary systems or waste, medical waste generation, we need optimized policies and decision making based on informed decisions. So in order to make informed decisions, we need access to data. So hopefully this integration of data across Europe will bring more optimized use of the available resources, MRI machines, computer tomographies, and not repetition of medical procedures where they are not necessary, not procurement of medical disposable items where they are not needed, but procurement where they are needed, so that we reduce the generation of medical waste. What is the problem with data? First, we gather data at the clinical encounter. Then we store this data in the electronic health record. Then we gather this into a research data set, and then we use it to build AI models. In each and every one of these steps, unless we have a standard, a mandatory procedure of processing this data, we are either going to omit some data or we are going to enter some wrong data, which will generate data inconsistencies that will later on generate wrong data analytics for non-optimized medical decisions and also biases in the AI models and policy. We do not want wrong data that will generate wrong decisions in policy, and furthermore, we do not want biased medical data that will generate wrong AI models. What are the issues that are causing unnecessary overhead in all these medical processes and policies that generate waste? Well, data fragmentation. We have non-interoperable regional silos, not only across European countries, but even within a country. Very often, different hospitals have their own silos, their own non-interoperable data bases and systems that cannot exchange data across regions. So even within a country in Europe, we cannot fully utilize the available healthcare records that can help us develop a more optimized, sustainable, ecological, and non-wasteful medical service, let alone across countries. Also, digital literacy among healthcare professionals should and will be improved so that we empower them to use AI tools more efficiently, again, in order to improve healthcare quality, but also reduce waste. We should avoid unnecessary medical procedures if we are well optimized across the healthcare services, and the governance of data, of course. So the European health data space will enable interoperable electronic health records that can be exchanged across regions in Europe. Federated learning, which is crucial and important because it enables medical data usage for research, but in the same time, fully complies with GDPR and healthcare data protection. So rather than bringing data to the algorithms in a centralized location, we bring the algorithms to the data in the original location where the data is stored. So we are not breaching any personal data protection rules because the data stays where it should in the local database where it was gathered from the patients. So we don't move this data anywhere in Europe. We bring the algorithm to that data in the micro location where the data is stored. So federated learning is a tool to generate AI models and to learn from previous patients so that we can invent new cures and optimize procedures and optimize the healthcare processes, not to generate waste, by applying the algorithms locally where the data is actually stored. By AI-enabled decision support, I hope that the decision tools will reduce diagnostic delays, improve personalized prevention, and of course, enable identical high-quality healthcare all across Europe. People carry wearable devices, self-monitoring that will generate new data used for research. As I said, I need to speed up because we're running out of time. Federated learning is an approach where the algorithm travels to the data rather than data traveling in a central location, enabling to protect national sovereignty of data, but also enable researchers to use data for new medical procedures and for optimized use of the medical resources, hence reducing unsustainable approaches in healthcare. AI should help medical professionals by being a tool for a better diagnostic and treatment procedures. We need to increase the digital literacy of healthcare professionals by increasing their knowledge of AI tools, and which will result in a decrease in waste because they will not do unnecessary medical procedures when they are not needed, and in the same time reuse clinical data that was already gathered. This is a vision.
Sorry, Ivan, one more minute, please.
Okay. This is a vision of how the European health data space will, by the end of this decade, will bring more data available to researchers so that we build a European-wide health governance policy and data for medical research. The idea of industrial symbiosis in the healthcare domain would mean valorizing medical waste through industrial networks, as the previous speaker mentioned. Supply chain, so more organized procurement of medical devices and tools so that we don't generate so much waste. And the vision is to have a unified, digitally grounded European health ecosystem where the clinical expertise, the patient autonomy, and the environmental sustainability will cover and will make minimum waste and a resilient, sustainable system. That's the vision. So that was my set of slides. Thank you for your attention. I'm available for discussions as you see fit.
Thank you so much, Ivan. Thank you so much for the presentation. For the moment, there is no question on the audience, so we are going to move for the last speaker for Vijay. So, Vijay, if you could share your screen.
Yeah. I can't share right now. I think if Ivan stops sharing.
Yeah, now I think you are available.
Yeah. Yes, can you see my full screen?
Yes, perfect. Thank you so much.
Yes. Thank you and good morning, everyone. And thank you, Almudena, for giving me the opportunity to present today. And myself, Vijay, master PhD student, going to graduate by next month. And I'm here to present my paper titled Circular Supply Chains and Industrial Symbiosis in Healthcare. And this work brings together two important perspectives. First of all is the circular supply chains within hospitals and industrial symbiosis across sectors to propose a more systematic approach to healthcare sustainability. And the healthcare sector plays a critical role in society. However, it also has a significant environmental footprint. Globally, healthcare contributes approx 5% of total CO2 emissions, and its reliance on single-use medical products generates large volume of waste. What is particularly important here is that many of these products are highly embedded materials and economic value. Yet they are disposed of after a very short use cycle. This highlights a fundamental inefficiency in the current linear model, which is take, use, and dispose. And the core problem we address in this paper is that of the high value medical devices, such as robotic surgery equipments, endoscopic systems, and the imaging technologies, which are often used once and then discarded, especially which are used during the surgery time. And this is not only because of the reuse is impossible, but also because of the regulatory constraints, lack of traceability, and misaligned incentives between stakeholders, plus plus the safety and insensitive material in the healthcare. And additionally, supply chains are fragmented and decision making is often risk averse due to the patient safety concerns. And as a result, valuable material are lost and circular opportunities remain underutilized in these healthcare systems. And this required cross-sector integration to solve this problem. This research here, we integrate two key concepts. First of all is circular supply chains, which focus on reuse, repair, remanufacturing, and recycling within the healthcare system. And second, industrial symbiosis, which extends beyond healthcare and connects waste stream from one sector as input to a resource to another. And the central idea around this is that the healthcare circularity cannot be achieved in isolation. Rather, it must be connected to a wider industrial ecosystem to make this possible. And to address this gap, like existing research has primarily focused only on the low volume consumable single-use devices and isolated hospital processes. However, there is a very limited empirical evidence on high value, low volume medical products moving across the entire value chain, from hospitals to suppliers, reprocessors, and recyclers. Furthermore, cross-sector collaboration through industrial symbiosis is largely missing from the healthcare circularity discussions. And this study aims to address this gap by providing a system-level perspective. And we do this. So the main objective of this research is to design and assess integrated circular and symbiotic supply chain models. And to answer this, we do it in 4 different research questions. And the first one answers that where are the major leakage in the current linear practices? And second, what condition enable this reuse, remanufacturing, and recycling of this healthcare products? Thirdly, how this industrial symbiosis can enhance circularity in the healthcare system and how better we can embed that in the current practice. And fourth, what governance mechanisms are required to support this transition? And this, with this slide, it illustrates the conceptual framework of the study. We map the flow of products from hospitals to suppliers, reprocessors, recyclers, and potentially other industries. In addition to material flows, we also consider data flows. Data flow, we also financial incentives and governance structure. This transforms the system from a closed healthcare loop into a broader circular ecosystem. And to illustrate this, like we have done, so in this figure, we show how healthcare waste becomes valuable resource through industrial symbiosis. And the industrial symbiosis layer connects healthcare outputs such as plastic, metals, and electronics to external industries for reuse and material recovery. Recovered plastics, metals, and electronics are further treated as certified inputs and redirected into different industries. Plastics go to the chemical sector, metals to the chemical sector, metal goes to the manufacturing, and electronics to the recovery system for valuable material extraction. And this process reduces emissions, saves resources, and improves supply security. Overall, the key message is simple. Healthcare waste is not a waste, rather it is an input for the different industries. And to conduct this study, we used a mixed method approach, which is conducted in Finland, specifically in collaboration with the Kuopio University Hospital and GE Healthcare Company, a major producer of the healthcare medical devices. we conducted semi-structured interviews across multiple departments, including the procurement, clinical unit, sterile services, logistic, and waste management people. And these interviews were complemented by the supply chain mapping, waste audits, and document analysis from the hospitals and from these companies. And this approach allowed us to trace product flows within the company and the hospitals in detail and identify both the barriers and enablers for practice of circularity and moving from the linear practice. And our finding highlights the three main insights. First, there are major leakage points, particularly at the post-use stage, where decisions about reuse or disposal are completely unclear. And secondly, several barriers exist, including the regulatory constant, liability concerns, and rigid procurement contracts. Third, there are clear opportunities such as designing devices for reuse, implementing take-back systems, and introducing digital product passport for traceability. Together, these findings show that circular supply chain are feasible but require a more structural changes from the base to the current to make these changes happen. In addition to this internal circularity, we identified strong potential for industrial symbiosis. For example, plastic components can be redirected to chemical recycling industries, metals can be recovered and reused in manufacturing, and electronic components which can be further processed through a specialized recovery system. Packaging material can also be repurposed as secondary raw material for the other industries, which the key insights here is that hospitals can act as a resource hubs within a larger industrial network rather than just an isolated waste generator system. And connecting the governance and public link, governance plays here a critical role in enabling this transition. So the key enablers include public procurement policies that prioritize circular solution, extended producer responsibility schemes, and risk-sharing contracting models. Digital traceability systems are also essential here for ensuring safety and accountability. Importantly, public institutions must act as a facilitator of cross-sector collaboration, linking the healthcare system with industrial partners and also reliving the current laws and practices around these products and devices. And this slide presents the proposed integrated model. So it consists of three layers. One is circular supply chains within hospitals, industrial symbiosis network across the different sectors, and a governance framework that will support both of this. And to make this model a success, it depends on aligning this material flow, incentives, and regulatory practice structures. And only through this alignment, it can be possible to achieve a truly systemic transition. And the implication of this study are significant. Environmentally, it can reduce emissions and waste. Economically, it enables value recovery and cost saving over a period of time. And for healthcare system, it enhances the resilience and reduces dependence on raw material. Overall, it supports a transition towards a sustainable and circular healthcare system. And to conclude, circular healthcare requires moving beyond isolated hospital practices towards the integrated cross-sector solutions. Industrial symbiosis offer a more powerful pathway to achieve this by transforming waste into a valuable resources. And with this study, we contribute by providing an evidence-based framework that connects supply chain, governance, and industrial ecosystem, ultimately supporting the shift from the waste management to value creation. And thank you for your attention, and I will be happy to take any questions.
Thank you so much, Vijay, for your presentation. There is any question from the audience? In the meantime, I have a question for you. You are mentioned this necessity of connecting the healthcare system with the industry, and all the conclusion that you have highlight, for example, this plastic component with this chemical recycling industry and so on. Have you planned to implement a pilot on the sense of working with several healthcare point and industry and try to see, let's say, more real environments or not?
Yes, this is a planning for a project for our further upcoming project work where we are planning a circular hub as a hospital and then connecting these findings. Like this was a conceptual work, and we are further continuing this work in a pilot and just see that how it can be how we can make it possible.
Thank you.
Thank you.
Any other question? Okay, so if there is no more question, just also to mention to Ophira that Anna answered in the chat or box of the question about the management plan and what they are doing in each of the plan and the difference between Vining and Copenhagen. So Anna, thank you as well. And I'm going to just close the session. I would like to thank you, the three speakers, to be here today and also to allow us to understand a little bit how other, let's say, less industrial sector like healthcare one need also support, but has a lot of potential for the implementation of industrial symbiosis, and also how we need European framework, as Ivan mentioned, with this health European approach. So, as always, the presentation will be sent to you by email, and the recording will be ready in a couple of days in our YouTube channel. So, thank you so much to all of you, and we will be connected in next webinar. Thank you so much.